No. Um Last time we started the topic of radioactivity, right? And in radioactivity, we discuss about the basic concept of the structure of an atom, right? We discuss about the structure of an atom, and we also discuss what are the number of mass number, atomic number, and how many protons, how to find out how many new electrons are there, how many neutrons are there. So we discussed all these concepts last time, right? Plus, we also discussed about the Rutherford gold foil experiment. And in Rutherford gold foil experiment, we also have three different concepts like observation, deduction, and reasons. So we studied about all those things. And the third important thing is related to isotopes. And last time we were talking about isotopes and we are like trying to solve the questions related to it. But that was the first time. So it was like difficult for the first time to solve the question related to the isotope. But today we also like continue with the same scenario to solve the questions of isotopes. Okay. Okay. So let's see. First of all, we start from the latest questions. Or you can also search from the file isotopes. Okay. Okay, this is the question. In this question, we have the topic of isotope, but this concept is completely different. We have to study this concept because this is related to radioactivity. But if we check, okay, this is also we need to study first of all radioactivity because in most of the question you will find decay, radioactive decay. After this decay, it happens, or after this decay, you will get this product with electron, with neutron, like this. So you will get different types of questions. Okay. So let's suppose, just for the reference to just revise the concept of the isotope, if you consider B part of this question, so in B part of the question, the most abundant isotope of protectetium is 231. This 231 is actually the mass number, right? Explain by referring to their nuclear composition why protactinium 231 and 234 are both isotopes of the same element. So by using their nuclear composition. So by using this idea, how we can explain this, these two, protactinium 231 and 234, both are the isotopes of same element.
Sir, because I guess the protons are different, right? Or the
Protons are
nucleons.
same and neutrons are different.
Oh, yes, sir, neutrons.
Yes. So this is the simple thing, or this is the basic idea to explain about the isotope, that they have same proton number. Okay. So in this, we also need to write the same answer, that both have same proton number. Because when two elements have same proton number, it means they are isotope of each other. And you can see their name are same, only their mass number is different. So we can write the
Uh,
answer. Yes.
Whenever it is like this, that uh, an element name is written and then there's minor, the value is negative, that means it's the mass or the number, atomic number or mass.
Okay. Basically, in this example, you can see there is the name of the element. Then this is not minus sign. This is like simple dash, then 231, right?
Okay,
And
it's
this,
for to show the
yes.
connectivity.
And this number is actually the mass number, right? So it always shows mass number.
Okay, so then
Hmm.
what change came in that made it isotope of the same element?
Basically, you can see we have 231 and 234, right? So they have same proton number, right? Like if you compare both quantities, so we have 231 and 234. And what is the difference of the values? There is the difference of 3. 234 minus 231 is equals to 3. So it means that this element 234 has 3 more neutrons, right?
Okay, sir. Yes.
Because we know the definition of isotope, that in isotope proton number or the proton remains the same, the number of proton remains the same. So in 231 and in 234, proton numbers remains the same, but only the neutron number or like the number of neutrons changes. Okay. Otherwise, all the quantities of proton remains the same. And in the same way, they are asking in the second part, explain by referring to their nuclear composition why protectetium 231 and 234 are different isotope of that element, right? In the first question, in the first part, they were asking about both are isotopes of the same element. But now they are asking are different isotopes of that element, right? So how we come to know that these are the isotope of same element, right? This is the question. So now we have to write the same answer that 234 contains three
Three
more
more neutron.
yes. Or you can write protectetium 231 has 3 less neutron as compared to 234. Okay. So this is the
Okay.
answer of this type of question.
Sir, the answer of part one is both elements have number of proton. Is that the answer?
Same. Have same. Same number of protons, right?
Okay.
Yep. So this is the answer for these two parts of the question, and most of the time, like with the name of different element, you will get the same question, right? They were asking about the same question in terms of nuclear composition, why they are same, why they are different, what is isotope, and how to show that these are the isotope of same element. So most of the time they ask this same type of question. I will also show you in this worksheet. Okay, I'm sending you the picture so you can take reference from there. If you check another question, so it will be helpful for you to find out how many type of questions are there in the same way. Okay, this is a slightly different question, right? Because in this question they are asking about ions. Do you know about ions? ION. If you know about ions, if you studied in chemistry. Otherwise, we will leave this question because we have to study this concept also, that what are
So
ions actually.
we'll learn ions today.
Okay, okay. Because in physics, there is very like not in very detail, but we just need to know about the basic idea that how to count the numbers or how to count the concept. Basically, the simple idea of ion is like if we have one element or if we have one atom. So if atom loses electron, right? Losing electron means it is like losing negative charge. Okay. And there is one more important thing in ions. It is mentioned ion in the question. So ions means either lose electron or either gain electron. Okay. So these are two possibilities. Why we are only talking about electron? Why not proton? Okay. Always remember, as you can see in the diagram also, that proton is in the nucleus, right? So proton is in the nucleus. So proton will not move just like electron. Because in atomic structure, we discussed that electrons are free to move or they are revolving around the nucleus. It is mentioned in the Rutherford experiment that electrons move around the nucleus. Okay. So always remember whenever we are going to talk about electron and proton, so only electrons can move from their position. Protons are not able to move from their position because they are in the nucleus. They are making the base of an atom, right? And if you move proton from there, so it means you are breaking down the base of an atom. Okay. I am repeating again. This is the basic idea. We will write in radioactivity the idea of this movement of proton in radioactivity, but there is a simple question because in ion you can see I only mention either we gain electron, either we lose electron. Okay. So the question is why we are not writing about proton because proton also have charge on it. So why we are always writing about electron, electron, electron? So reason is very simple. You can see electrons are free to move. Okay. But protons are in the nucleus. And proton is making up the center of the atom, the nucleus of the atom. So that is the base of an atom. Okay. And if you try to move the base of anything, right? So definitely that structure collapse. So that's why proton is not able to move like electron. Okay. So always remember this concept. Okay. Now the second thing is, for example, if element is going to lose electron, it means you are losing negative charge. So when you are losing negative charge, so definitely we are getting deficiency of electron. Okay. Clear? Any confusion?
No.
So when you are losing negative charge, so you are getting more positive charge on your body because you are losing negative charge. So there is deficiency of electron. Okay. So when some element or some atom or any specific element or atom loses electron, so it becomes positively charged. or we can say positively charged ion. Okay. So this is the concept of ion. Like if you lose electron, so definitely there is the deficiency of electron. And when there is a deficiency of electron, so it means the number of positive charge is greater than the number of negative charge in an atom. If atom loses electron, okay, not in normal state, but in the state of losing. Okay. But let's suppose if one element is losing electron, so some other element gain are going to be like grab those electrons, they will gain those electrons. So the element or the atom that actually gains electron, so that becomes more negatively charged, right? So that is called negatively charged ion. Okay.
Sir,
Yes.
if we will never lose new protons, right, and neutrons, we won't lose protons and neutrons, or is there any case that we might lose them as well?
No, basically, if there is a chance of losing or gaining, so only electron can be lost or gained, right? There is no chance
Okay,
of losing proton or gaining proton, right?
okay. So,
Because
sir,
Hmm.
ions, when electron is the electron is not present and it loses its charge, so then it demotes or degrades to the particle ion, or ion comes from somewhere else.
Okay, basically, ion is like we can say it is like a situation. Okay, ion is a situation, particular situation, and when we will get ion situation, so you will get ions in two categories, right? Either you lose electron. For example, we know that in our human behavior, we have like some people have negativity in their behavior, right? So let's suppose if some person is like is going to avoid negativity, so it becomes more positive, right? You will say that this person is very positive. Okay. So in the same way, when you are losing electron from an atom, for example, if there is like 20 electron, and after losing electron, you will only get 18. Okay. So there is a loss of 2 electron. You transfer these 2 electrons to some other element. But you know that number of proton remains same. Okay. And we are not losing protons. Protons remain same. So when proton remains same, now you can see we have 2 more protons as compared to electron, right? So it means this body becomes positively charged. Okay. And in the same way, like if we have another element and that element gains electron. So we have another element and it gains electron, that is actually loses by the first element. It becomes 22 electron and proton remains the same.
Okay, so sir, E is the symbol of,
Charge, either positive charge, either negative charge, right?
okay, positive. If there's a minus sign over the E,
Yes.
that means it's electron, and whereas if there's a plus
Positive
sign, then
sign,
it's a
proton.
proton.
Actually, this is
Okay,
the short way to represent proton electron, right? Otherwise, it is not in syllabus anywhere. Like you will get marks for this. Okay. You can also write complete 20 or like positive charge or 20 proton, but this sign helps to like represent in short way, right? So that's why I'm writing this symbol. But right now there is no specific need to write down this symbol anywhere. Other like you will not get any specific marks right now of writing this symbol because in our question we are writing in proper description, right? So the question is related to ion. Now let's see what they are asking about the ions. So the question is, we have another element that is called thorium, And one more thing, they will not ask about the definitions of ion in physics, right? That's why I only tell you about the specific part that is important for physics only. Okay. When you study this topic in chemistry, so definitely you will study over there in very detail, right? So you will get more idea over there. But in physics, I only tell you about the specific part that is important for physics syllabus. Okay, because in physics we only are going to discuss about either gaining or losing. That's it. We will not discuss that this is the structure of atom and what type of ionization will take place over here. This is the part of chemistry. Okay, so you will discuss this concept in detail over there in chemistry. Okay, because if like teacher asks you about ionization and you only tell this, so this is the basic thing, right? But if they ask further about it, so we are not going to discuss that detail in physics, but definitely you will study that part in chemistry. So question is, we have another element, thorium-229, and it is radioactive isotope. We will discuss what is radioactive. Radioactive means it emits radiation, right? Just like X-rays. And it is used in several medical applications that involve alpha particle, beta particle. Okay, just ignore this alpha or beta right now. Okay,
Okay,
now
so
the basic idea that we are going to discuss is in first part. Okay, because we discuss about so much about ions, and it is mentioned during ionization, a helium atom becomes helium ion. So helium atom is a normal atom, right? It becomes helium ion. Okay, helium atom is actually like this: 2He4. This is helium. So how many protons are there in helium?
the protons are written down, right?
Yes.
Two.
So there are two
Two
protons and
and
definitely two
four.
electrons, right? Because proton electron are
Yes,
same.
Yes, sir.
four neutrons then.
Two neutrons.
I mean, okay.
Yeah, right? Because always remember, this is also the example of helium, right? Because the top number shows you proton plus neutron. And if you are going to find out neutrons only, so always remember this, we have to subtract them. Okay. Okay. Now we have ions. And it is mentioned a helium atom becomes helium ion. Okay. And helium ion is given in the diagram. Okay. So in this diagram, you can see there are two protons. It means that definitely there are two electrons in the like around the nucleus. So for example, these are the two electron to balance these protons. Okay, because this is the natural thing that proton number, electron number always remains the same, right? Any question, any confusion?
Sir, there's already another electron over there that is labeled by the name of electron.
Yes, because they clearly show because these are the sphere. So we don't know what is actually sphere in this diagram represents. So that's why you will get the name. And
Okay.
these are neutron.
Uh, Sir, I also have a doubt.
Yes.
The E is the E represents
E
electrons, right?
E
So
represent.
how is it positively charged?
Yes. Basically, we are using the symbol of E to represent charge. Okay. And when we write positive, E positive means protons. Okay. And when we write E negative, it means electron. Okay.
Okay, sir.
E symbol actually we are using for charge. If we write plus, positive charge. If we write minus, negative charge. Okay. So in this question, we have helium atom and helium ion. And in this diagram, you can see we have helium ion. Okay. And it is mentioned in the question that helium ion is He positive, right? So this is the diagram of He plus ion. Okay. So according to this structure, now we have to explain that what will be the answer of the question they are asking about. Now, this is very important. So try to like focus on the question that what they are actually asking about, because now we studied about isotope. So we know about isotopes, and now we are also going to answer about ions. Okay, so don't mix the concept, keep them separate and then try to answer the question. First of all, in the first part, they are asking about helium ion. Okay, so the question is, state how the structure of an helium atom differs from the structure of the helium ion. Okay, so they are asking about the difference between helium atom and helium ion. Okay, so in helium atom, as you already mentioned over here, this is the helium atom. So there are two protons, two neutrons. So you all know that in helium atom we have two protons, two neutrons. Okay, but
Okay.
if we talk about helium ion, so you can see in helium ion what is happening. Uh, if we use a different color, okay. In helium ion, what is going on? We have two proton, we have two neutron. It is clearly shown in the diagram. We are not writing by ourselves, we are writing from the reference of the diagram. Or the third thing is, you can see there is one more electron shown in the diagram. Okay, this one. So what is this? Okay, because we mentioned there are two electron, there are two electron, because we know number of proton, number of electron are always same, right? But there is one more electron given in the diagram. So what is the meaning of this? This is because of ion, right? This is the state of the ion. This is not the normal state. This is the state of ion. Okay. So basically what is happening over there, it is mentioned He plus. He plus means it is a positive ion or a negative ion. He plus means positive ion.
Positive.
Yes. So according to the positive ion, what do you think? It will lose electron or it will gain electron?
It lost
Lose
electron.
electron. Lose electron. Good. So basically, this is the difference, right? Now we have two proton, two neutron, and two electrons in the helium atom, right? But when we are talking about the helium ion, especially He plus ion. So in He plus ion in diagram, we can see there are two proton, there are two neutron, but there are no more two electrons, because in picture you can see there is only one electron given, and in question it is mentioned this is He plus ion. It means it loses one electron and it becomes only one electron. Okay, according to the diagram. So according to the diagram, we can answer the first part, that in structure of helium atom, in helium atom we have two electrons, but in helium ion we have only one electron. Okay, so helium ion has deficiency of electron as compared to helium atom. Clear?
Yes, sir.
So the answer is there are two electrons in helium atom, which is natural, or we can say the normal state, but only one electron in helium ions. Okay, so this is the difference actually, and don't worry about it. You will always get some type of example in physics, especially because we are not talking about chemistry right now. So we are not going to discuss about very much deep detail, because that is not necessary in physics right now, in this chapter right now especially. So don't worry about it. Always you will get some type of hint or some type of diagram in your question. Just like in this question, you will get a proper diagram, and from that proper diagram it is clearly mentioned in the question that it is He plus, it means positive ion, and there is also electron given. Okay, so you can easily identify from there. Now if we compare with the second part, so that is related to alpha particle, right? And definitely you don't know about alpha particle because we have to study this part. Okay, so just ignore that part. So now you can see we can also compare atom or normal structure of an atom with the structure of an ion. This is very simple.